It was early on the morning of December 17th when observatories across the Northern Hemisphere began to report the same thing, an unmistakable shift in the colour profile of 3i Atlas. This wasn't a small adjustment. This wasn't noise in the signal. This was a transformation that had been building slowly, frame by frame, until suddenly, it wasn't subtle anymore. From Alaska to Chile, from high-altitude telescopes in Spain to deep space tracking systems in Japan, astronomers began logging the same observation. The object was turning green. Not faintly, not in streaks, but completely. Vivid, glowing, emerald green. By noon, the intensity had climbed 33 times above its previous baseline. The colour wasn't just visible in spectral analysis anymore. It was visible to the naked eye through telescopes pointed at the right section of the sky. It shimmered like a gemstone. It pulsed like it had a rhythm. And then, as it approached Earth's orbital line, it did something even stranger. It stabilised. Instead of scattering particles, it seemed to coalesce. Instead of slowing, it moved in sync with Earth's motion for a full hour. And most disturbing of all, there was no outgassing, no tail, no disruption from the solar wind. Just one glowing green object, moving with intention. Comets don't do that. Asteroids don't glow. No known interstellar object has behaved like this. Not Oumuamua, not Borisov, not any of the hundreds we've tracked since. And that's what makes 3i Atlas different. Because this one wasn't passive, this one changed. And the closer it got to Earth, the more vivid, more deliberate those changes became. Today we trace every strange movement, every unexplained spike in brightness, every anomaly in its green spectrum, and ask, what is this thing actually doing, and why now? Let's begin. It was the kind of observation that begins with silence. No headlines, no press releases. Just a strange signal buried in a stream of raw telescope data. On the morning of December 17th, a team of amateur astronomers in northern Spain noticed something different in the visual profile of 3i Atlas. They weren't expecting it. No alerts had gone out. No change was predicted. Yet the colour readings coming from the object's coma, normally whitish-grey and faintly blue from solar reflection, had shifted. Not slightly, not subtly. The readings showed a dramatic increase in green light emissions, more than 30 times stronger than what had been measured just a few days prior. At first, the assumption was a calibration error. Instruments sometimes misread a single colour channel. Sometimes a lens fogs up. Sometimes a software filter applies the wrong correction curve. But then came the confirmations, first from Chile, then from the Czech Republic, and finally from an independent researcher in Queensland using a robotic telescope mount. All of them were seeing the same thing. The object that had been dull, cold, and nearly invisible in colour intensity was now glowing green. And not just any green. This wasn't the faded jade hue of terrestrial auroras or the misty neon seen in distant nebulae. This was an aggressive, pulsing green. Bright enough to register through urban light pollution, dense enough to saturate mid-tier sensors, in some cases bright enough to overload narrowband photometers tuned to detect common cyanogen emissions. The signature was unmistakable and alarming. To understand why this mattered, you have to understand what comets typically do. When they approach the Sun, their outer ice layers begin to sublimate, turning directly from solid to gas. This forms the coma, a cloud of dust and gas that reflects sunlight. The composition of the coma determines the light it reflects. Water ice, carbon monoxide, and simple hydrocarbons all play roles. Occasionally, if there's a lot of diatomic carbon, C2, in the coma, a faint green glow can emerge. This is natural, and it's been observed in comets before, but never like this. Not with this strength, not with this speed, not this close to Earth. What makes 3i Atlas different is both the magnitude of the colour change and the geometry of the glow. Most green-glowing comets develop their colour gradually as they get closer to the Sun, and their inner volatiles begin to react with solar radiation. It's a slow, outward blossoming process. But 3i Atlas had already passed perihelion, its closest approach to the Sun, weeks earlier. If anything, its activity should have been winding down. And yet here it was, emitting more green light than ever, just 2 days before reaching its minimum Earth distance. The glow wasn't diffuse or scattered. It didn't resemble a gas halo expanding into space. It was tight, dense, focused around the core of the object and extending into certain structured regions of the tail. The green signature wrapped around the nucleus like a coil, flaring at specific angles, dimming at others. Observers noted that it didn't behave like reflected light at all. It behaved like emission. That single distinction changes everything. Reflected light is passive. It tells you about the surface. Emitted light, on the other hand, suggests energy. It suggests something active, something converting input into output. And that raises a troubling question. Why now? Why this close to Earth? Why after perihelion, when activity should be fading? The colour that shouldn't be there was not only there, it was growing stronger, and nothing in current comet models can explain it. In most cases, when a comet begins to glow, scientists look to a familiar mechanism: fluorescence. It's one of the oldest, most reliable explanations for why certain comets appear to shine with colour, especially green. And typically it comes down to a specific kind of molecular interaction. Ultraviolet radiation from the sun strikes certain gas molecules within the comet's coma, usually cyanogen, Cn, or diatomic carbon, C2. These molecules absorb high-energy UV photons, and as they return to a lower energy state, they release visible light. This process is called fluorescence. It's well documented, easy to model, and entirely natural. But the green emission from 3I Atlas on December 17th wasn't behaving like textbook fluorescence. The first problem was intensity. Diatomic carbon does indeed fluoresce green under the right conditions, but only a tiny fraction of comets produce enough C2 to be visibly green to the naked eye. And even then, the glow is usually faint and uniform, spreading out evenly in a hazy spherical shell around the nucleus. It's diffuse, like fog caught in a flashlight beam. But with 3I Atlas, the glow wasn't faint or uniform. It was sharp. It was spatially concentrated. It wasn't forming a halo. It was tracing lines along the body and tail, clinging to certain structures and skipping others. If the green light were coming from simple gas excitation, we'd expect a smooth, isotropic glow. Instead, we got structure. Contours of light that suggested the emissions weren't coming from gas randomly moving in space. They were originating from something stable, something physical, possibly even the object's surface. That changes the physics dramatically. Because fluorescence doesn't usually happen on solid surfaces in comets. It happens in gases, unbound molecules that float away from the object after sublimation. For fluorescence to be this strong and this structured, either the coma would have to be incredibly dense, denser than anything observed so far, or the light wasn't coming from gas at all. That leaves one other option: surface-bound luminescence, which would imply a material on or near the nucleus that's absorbing solar energy and re-emitting it in specific wavelengths. Here's where it gets even stranger. If this was C2 fluorescence, we'd expect to see a spectral peak around 516 nanometers, the so-called swan band. And yes, telescopes did detect emissions in that zone, but they also picked up something else: harmonics in nearby wavelengths that didn't match C2, Cn, or any other known cometary compounds. Observatories in Chile and Hawaii independently recorded a spike around 520 to 524 nanometers, just a few nanometers off the swan band, but outside the expected error margins. That signal was stronger than the baseline C2 emission and didn't match any standard model. Some researchers propose contamination, maybe an error in the detector, maybe a calibration issue, but that was quickly ruled out when different instruments on different continents produced the same readings. Whatever was producing that extra glow, it was real. It wasn't noise, it was part of the comet now. At this point, the idea of a gas-based explanation started to fall apart. The spectral width was too broad, the intensity was too localized, and the geometry was wrong. Fluorescence should soften with distance, fading at the edges of the coma. But in this case, the green intensity dropped sharply at specific angles, as if blocked or masked by something physical. That behavior resembles an emission surface with directional output, more like a glowing object than a cloud. So if it's not traditional fluorescence, then what is it? One theory suggests exotic surface chemistry. Maybe something on the nucleus, some carbon-based or metallic compound, was reacting with solar UV in a way we haven't observed before. Another theory leans toward artificial luminescence, a process in which material absorbs solar energy and re-radiates it, not because of random chemistry, but because it was designed to. That idea is still considered fringe, but the data is pushing some scientists toward reconsidering. Because even if this object is natural, it's clearly not following the rules we've written for comets. Fluorescence may have started the conversation. But with 3i Atlas, it no longer explains what we're seeing. Spectra are the fingerprints of the universe. They don't lie. When we point our instruments at distant stars, planets, or comets, what we're really doing is splitting their light, breaking it into wavelengths and reading the code hidden in each band. Every molecule, every element has its own spectral signature. Oxygen glows red and green in auroras, sodium burns yellow, hydrogen reveals itself in faint violet pulses. In this language of light, we decode the physical makeup of worlds we may never touch, but 3i Atlas just confused the system. When the green surge began on December 17th, teams around the world turned their spectrometers toward it. They weren't looking for visuals, they were listening for chemistry. And at first, everything looked familiar. A strong, clean peak near 516 nanometers, right where we expect to see the swan band from diatomic carbon, or C2. This is typical in comets, especially those with highly active cores and fresh gas release. But then the instruments picked up something strange. Just above that expected line, at roughly 520, then again at 524 nanometers, there were additional peaks. And they weren't weak echoes. In some cases, they were stronger than the original C2 signal. Observatories in Hawaii, Chile, and Western Australia all confirmed the anomaly. These weren't secondary harmonics or statistical noise. They were repeatable, stable, and completely out of place. What made it worse was that they didn't match any known compounds, not from standard comet models, not from known interstellar volatiles, not even from rare terrestrial contaminants. They were just there. Solid lines in the data with no known source. At first some blamed interference, nearby satellites perhaps, or passing solar noise, but the lines didn't drift. They stayed locked to the object's position, moving in sync with 3i Atlas across the sky, across hours of observation. And they didn't appear in background sky readings, only in the light directly from the object. That meant one thing: the emissions were real, and they were being produced by something on or near the comet itself. This is where theory began to splinter. One group argued that exotic ices could be responsible, compounds that only form under deep interstellar radiation, molecules with unstable bonds that shatter into unexpected fragments when hit with solar UV. This would imply 3i Atlas carries chemistry from beyond the conditions we've studied, perhaps forged in the outer disk of a different star system, or altered by cosmic ray bombardment over millions of years. But even those extreme models struggle to explain the intensity of the peaks, and more importantly, they couldn't account for how localized the emissions were. Standard sublimation spreads gas into a coma. The resulting fluorescence should appear as a soft cloud, broad, diffuse and fading with distance. Instead, 3i Atlas's spectrum told a different story. The strongest emissions came from regions closest to the nucleus, from areas where gases should have already thinned, from lines that stayed tight and sharp in wavelength, meaning the emitting material wasn't moving randomly. It was staying near a stable zone, possibly even a surface. This brought up an uncomfortable parallel. In artificial systems, like ion engines, plasma chambers, or photonic reactors, similar spectral profiles are sometimes observed. Highly energetic emissions with controlled spatial geometry. Emissions that aren't the result of chemistry alone, but engineering. Of course, no one is saying 3i Atlas is a reactor, not publicly. But even conservative researchers now admit that the spectral data doesn't fit natural comet models. One astrophysicist from the Max Planck Institute simply wrote, "There is structure here that we do not understand. The spectrum is behaving like it was designed." That word, designed, echoed across forums, whispered in private email chains, and stirred unease among the most cautious scientists, because a natural object might be complex. But a natural object with a spectrum that mimics systems we build ourselves, that's something else entirely. Comets are, by their nature, messy. They're often called dirty snowballs for a reason. Frozen cores wrapped in layers of dust, rock, and volatile ices that sublimate as they approach the sun. That sublimation process creates the coma, a billowing envelope of gas and dust that obscures the object's surface and makes direct observation nearly impossible. By the time a comet becomes bright enough to see from Earth, its face is already hidden behind layers of its own debris. But on December 17th, something happened to 3I Atlas that no one expected. The dust didn't just thin, it appeared to clear, and in some places, it looked like it vanished entirely. Images captured across 3 continents from observatories and backyard telescopes alike began to show the same thing. The green light we talked about earlier wasn't simply being scattered through the coma, it was piercing it. It was outlining the shape of the object itself. You could trace the contour of the core, not as a guess, but as a visible structure surrounded by light. For astronomers who spend their careers peering through haze and approximating surface features by indirect means, this was surreal. One observer described it as watching fog part to reveal a tower. Another simply said, it looked like the dust gave up. But the implications go far beyond visibility. The coma is supposed to be optically thick, especially during peak activity. It's formed from ejected particles, many just microns in size, that should scatter and absorb light across the spectrum. This scattering is what gives comets their fuzzy, glowing appearance. It's why most appear as little more than luminous blobs with vague tails. You can't see through a coma, not with visible light, not easily. So why could we now? One theory is that the dust itself changed. Under certain conditions, extreme heating, magnetic alignment, or unusual particle composition, dust grains can behave more like crystals than smoke. They align. They polarize light instead of scattering it, and in rare cases they allow certain wavelengths to pass through with minimal diffusion. But there's no record of this ever happening in a comet before. Not at this scale, not to this effect, and certainly not with green light punching through like a spotlight from within. Another possibility is that the green glow itself altered the dust, either photochemically or electromagnetically. If 3I Atlas is emitting structured energy from beneath its coma, that energy might be pushing particles outward in a way that clears lanes, like invisible radiation corridors blasting holes in the fog. In some of the clearest images, a cone-shaped window of clarity appeared on the sun-facing side of the object. This wasn't a photographic artifact, it was confirmed from different latitudes and viewing angles. The green emission streamed through this window unimpeded, illuminating the edges of the nucleus and forming a halo that was unnaturally sharp. So sharp, in fact, that filters had to be adjusted to prevent oversaturation. This has led to a more radical hypothesis, that the coma isn't thinning naturally at all. Instead, something beneath it might be actively managing the dust, shaping it, pushing it aside, clearing lines of sight through mechanisms we don't yet understand. Think of it like a submarine parting water around itself, or a drone hovering in a cloud and pushing vapor away with directed heat or air pulses. Could this be a coincidence? Sure, comet dust is notoriously unpredictable, but the consistency of these clearings, their alignment with surface features, the way they matched the object's rotation, suggested something organized. And that's the problem. Dust isn't supposed to organize, it isn't supposed to cooperate with light, and it certainly isn't supposed to make a comet's surface easier to see just days before its closest pass to Earth. But 3I Atlas continues to behave like it has a plan. And now, for the first time, we might be seeing its skin. Tails are expected. In fact, they're iconic. When most people think of a comet, the image that comes to mind is that long luminous streak trailing behind it. That's the dust tail, a product of solar radiation pushing particles away from the nucleus. There's also the ion tail, made of charged particles interacting with the solar wind, usually fainter and straighter. These features behave predictably, always streaming in the direction opposite the sun. But on December 17th, 3I Atlas did something that sent comet physics into a spiral. It lit up its anti-tail, and not just with reflected light, with green emission. Now, to understand how strange this is, you need to know what an anti-tail is and what it isn't. An anti-tail is not a real tail in the traditional sense. It's an optical illusion caused by Earth's changing viewpoint as we pass through the orbital plane of a comet. What appears to be a tail pointing toward the sun is actually a sheet of larger dust particles left behind in the orbital path which from our angle stacks into a dense visual line. It's geometry, not physics. The anti-tail isn't really pointing at the sun, it just looks that way. And importantly, it doesn't glow. It reflects, and not well. Anti-tails are made of old material, slow, heavy dust particles that aren't energized. They're essentially inert. So when multiple telescopes across the globe began reporting a green hue within the anti-tail of 3I Atlas, alarm bells rang. Because that's not how this works. Observers first noticed it during long exposures from Eastern Europe. The main tail was behaving normally, bright, directional, aligned with solar wind vectors. But a thin, almost filament-like structure was developing in the opposite direction, and it wasn't grey, it wasn't faint, it was green. At first, this was dismissed as bleed over from the core glow. The logic was simple. If the central nucleus was emitting green light, maybe that light was diffusing outward and contaminating the view of the anti-tail. But subsequent observations ruled that out. The glow in the anti-tail wasn't random. It had structure. It followed a narrow path directly along the densest axis of the anti-tail, a path that moved and intensified with the rotation of the object. Even more puzzling, the brightness of this green streak fluctuated on a schedule. Observers from Italy and Argentina noted spikes in green emission every 90 minutes, almost in sync with the pulses already being recorded in the nucleus. This wasn't diffusion. It was coordinated, deliberate. So the question became, how? For the anti-tail to glow, something has to energize the dust within it. But this dust is old, far from the surface, and no longer in active contact with the nucleus. It should just float there, inert and dark. Yet here it was, flaring green like a neon signature in deep space. There are two possible explanations, both uncomfortable. The first is that energy from the nucleus is somehow reaching the anti-tail, perhaps in the form of directed radiation, infrared or microwave bursts that energize particles and induce visible emission. But this would require a level of control no known natural object can achieve. It would mean 3I Atlas is capable of projecting power in a targeted way, like a lighthouse beaming light across space. The second possibility is even more radical. What if the anti-tail isn't entirely made of dust? What if, embedded within that stream of particles, is a trail of material being intentionally left behind? Not ejected randomly, but placed, perhaps as part of a system that reacts to solar input, stores energy, and emits light when triggered by orientation or timing. If that's true, then what we're seeing isn't just debris. It's a component, a part of something larger than the core. Some scientists hesitate to even comment on the idea, but the data keeps pushing the line. The green in the anti-tail isn't an illusion, it's measured, it's real, and it's behaving like it was designed to be seen. Whatever 3I Atlas is doing, it's not just about surviving solar exposure. Now it's about direction. Because when a tail points toward the sun and glows, we're not observing an accident, we're witnessing a message. There's something uniquely unsettling about patterns in space. Not random craters or chaotic outgassing trails, but true patterns, organized, repeating, geometrically sound. Nature favors chaos at cosmic scales. It smears, cracks, sputters, and scatters. So when a celestial object begins showing symmetry, structure, or alignment, it often means one thing: it's not entirely natural. The morning of December 17th gave us more than just green light. It gave us contrast. The comet was now close enough, and active enough, for high-definition imaging to reveal something that had previously gone unnoticed: surface markings that weren't random. At first glance, the nucleus of 3I Atlas looked like any other hyperactive comet, glowing, rotating, ejecting gas and dust in irregular jets. But embedded within the fluctuations of light was something sharper. A series of darker zones, slightly cooler regions, arranged around the nucleus in a pattern that seemed, if not artificial, at least mathematically consistent. Thermal imaging from both the Apex array in Chile and the upgraded spectrometers aboard ESA's tracking satellites began returning strange heat maps. These weren't pixel-level noise artifacts. They were persistent formations, 3 darker bands evenly spaced circling the mid-latitude regions of the comet's surface. Thin, precise, and parallel, almost like planetary rings, except burned into the object's shell instead of floating around it, and they weren't static. Over the next few hours, those bands shifted. Not in location, but in temperature. Spectral readings indicated that the bands went from slightly cooler than the surrounding surface to suddenly warmer, then cooled again, then pulsed in a rapid cycle, roughly every 12 minutes. What should have been dead surface crust covered in ancient cosmic ice was pulsing like a heart. Now this isn't how comets work. A normal comet rotates. It heats up on the sun-facing side, vents some jets of gas, spins again and repeats. Any hot or cold spots are the product of sun angle and terrain shape. They don't pulse. They don't blink. But these bands were blinking. What does that mean? It means we're dealing with an object that's either being controlled internally or responding to something in real time with an absurd level of precision. To pulse in perfect timing over 12-minute cycles, the energy source behind it would have to be buried deep within the core and consistent enough to regulate emission at surface level. Some observers proposed natural resonant heating. Maybe the object has cavities inside it that amplify certain heat cycles, like waves in a cave. But that wouldn't explain the perfect spacing, or the symmetry, or the fact that each band responded at exactly the same time across different hemispheres without lag. Others went further. They asked the question no one wanted to ask. Are we looking at engineered behaviour? It's still taboo in most scientific circles to even raise the possibility. The idea that a comet, something we've catalogued for centuries, could be anything but a frozen leftover from the solar system's early days is heresy to textbook models. But 3i Atlas doesn't care about our models. It's doing what it wants. And what it did on December 17th was unmistakable. It presented its surface, not randomly, not through erosion or chance, but by heating its outer shell in coordinated, deliberate pulses, as if to say, here I am. NASA's internal logs confirmed the readings. So did the Japanese Space Agency's infrared instruments, and yet no official statement has been made. Just a silent row of acknowledgements across global observatories that something unprecedented is happening on the comet's skin. If it were just green light, we could have explained it away. If it were just a strange orbit, we'd point to gravitational anomalies. But coordinated surface heating, aligned thermal bands, that suggests intent. And in space, intent is everything, because space doesn't blink on a schedule unless something in it wants to be seen. As the surface bands pulsed, the space around 3i Atlas responded. Its coma, already vast, began to expand in a way that violated everything we've modelled about cometary behaviour. Comas form when solar radiation strikes a comet's nucleus, vaporizing volatile ices and releasing gas and dust into the surrounding vacuum. It's messy, diffuse, and often chaotic. But on December 17th, the coma around 3i Atlas didn't just grow, it bloomed. That's the only word scientists at the South African Astronomical Observatory could agree on. At 4:42 UTC, a thin green layer separated itself from the existing coma and radiated outward at a consistent velocity. This wasn't random off-gassing, it was synchronized. Observers described it as watching a flower open in slow motion, except it wasn't a flower. It was a high-velocity halo of particulate energy expanding outward with deliberate precision. And then came the twist. Instead of thinning as it spread, like any normal cloud of ionized gas would, this new outer coma layer held its density. From multiple stations, Chile, Hawaii, France, even the high-latitude Dome Sea Station in Antarctica, light refractometry confirmed the particle concentration in the outer shell remained remarkably consistent even 30 minutes after release. That doesn't happen in nature. Under normal physics, gas spreads out. It thins as it travels. But this green shell didn't. It maintained its structure as if something was holding it in place. Some field, some force, some internal control. And the colour wasn't uniform green either. It contained gradients, wave-like undulations of deeper emerald hues, circling the comet like auroral rings around a planetary pole. The entire scientific community watching live feeds from ground-based telescopes was stunned into silence. We've seen comets release jets. We've seen fragmentation events, but never an organised, symmetrical, high-density shell that radiates outward with the same geometric order as a man-made detonation, but without the chaos, without the heat signature, and without dispersal. And still, 3i Atlas pulsed. Every 12 minutes, like clockwork, the surface bands blinked, and each time the outer coma responded, not violently, not in a burst, but in a smooth rhythmic amplification, a breath, in, out, in, out. The object wasn't just emitting particles, it was regulating them. That's not what a comet does, it's what a system does. Astrophysicists immediately tried to simulate the behavior in lab models, the closest match. Controlled plasma containment experiments using magnetohydrodynamic rings, technology we've barely mastered here on Earth for fusion research. Except 3I Atlas isn't in a reactor, it's in open space, with no walls, no magnets, and no known reason for its coma to behave this way. By mid-morning, ESA's Solar System Monitoring Division quietly updated its public telemetry feed. No announcement, no warning. But if you were watching the data stream closely, you would have seen it. A new tag applied to the object. Energy modulation suspected. It's the kind of label that only appears when internal energy redistribution is observed, like inactive satellites or malfunctioning probes. But this wasn't a probe, at least not one we made. And then the green light intensified again. Not from the comet itself this time, but from the expanding coma. Spectral analysis showed increasing ionization in the new outer shell, suggesting an active energy transfer occurring not just at the nucleus, but across the field of the entire coma. In essence, the space around the object had become part of its system. It wasn't shedding mass like a dying comet. It was establishing a field, a living one. For the first time in decades, the International Astronomical Union's Emergency Response Team sent out a Level 3 object behavior alert. Not for collision risk, but for physics deviation. Something is managing this object's surroundings, something we've never seen before. By mid-morning on December 17th, as the green coma expanded and held its impossible shape, a new alert filtered across deep space monitoring stations, this time not from optical or spectrometric instruments, but from radio telescopes. It started with something faint, just above the ambient cosmic background, a low-frequency pattern buried within the noise. At first, operators dismissed it as internal interference or solar echo, but the signature persisted, and when they isolated it, something startling became clear. The emission wasn't random, it was rhythmic, every 12 minutes, perfectly in sync with the surface band pulsing observed in earlier visual and infrared wavelengths. This meant the green coma and the light pulses weren't the only signs of modulation. Something deeper, something embedded within electromagnetic space, was resonating outward from 3I Atlas like a heartbeat. The Parkes Observatory in Australia, which had previously been monitoring the Voyager signals, pivoted to confirm the anomaly. Within hours, 3 more arrays, FAST in China, Meerkat in South Africa, and the Allen Telescope Array in California, replicated the same readings, and it got stranger. The pulse was not a simple sine wave or fluctuating burst. It carried internal structure, subharmonics within subharmonics, like chords inside chords. Some researchers began referring to it informally as the green code, because of its correlation with the shifting hues of the expanding coma. What did it mean? That's where the speculation started to fracture into 2 camps. One group, grounded in traditional astrophysics, suggested this could be a naturally occurring magnetic oscillation. Perhaps the object had internal cavities filled with conductive plasma, allowing for cyclic current loops, which in turn emitted periodic radio signals. That would still be groundbreaking, but not unprecedented. Certain pulsars and gas giants exhibit electromagnetic harmonics, but the other group wasn't so sure, because of one simple fact: the signal changed. At 10:14 UTC, observers across multiple facilities reported a deviation. The core frequency split. Not once, not randomly, but with precision, as if the object was switching bandwidths. Some described it as a handshake, others as a code shift. It was no longer just pulsing in sync with the surface activity, it was responding. That's when a quiet wave of internal silence fell over agencies. Public data streams went offline, scheduled press briefings were postponed. Even social media posts from telescope teams became unusually generic. There was a sudden shift in tone, away from curiosity toward caution. Some of the most experienced scientists said nothing at all, not because they had no answers, but because they feared the implications of what they were observing. A signal that syncs with visual light pulses, a coma that expands with coherence, a comet that behaves like it's aware of its surroundings. And now, a radio emission that modulates itself as if interacting with its environment, or with us. To most people, this kind of behaviour would sound like science fiction, but to those watching the data unfold in real time, it felt like something new, not a spacecraft, not a comet, but something in between, a transitional object, a system capable of communication, but on terms we don't understand yet. The United States Deep Space Network briefly updated its tracking notes with a cryptic sentence: "Non-random modulation under analysis, no further comment." But others started talking, quietly and off the record. One leaked email from a lab technician in Chile described the signal as too clean, too repetitive, and way too precise for background noise. It wasn't broadcasting, it was tuning, and that meant the green wasn't just a glow, it was a veil, a membrane, a field of resonance and possibly a carrier of information. If that's true, then Earth isn't just an observer anymore, it might be the recipient, and whatever message 3i Atlas is sending, it just got a lot more personal. Roughly 10 minutes after the modulation shift in the radio band, something happened that changed the narrative entirely, from distant mystery to earth-bound consequence. In Alaska, a team of atmospheric physicists had been monitoring the polar ionosphere for minor geomagnetic fluctuations. This is routine work. The polar regions are constantly absorbing cosmic rays and solar wind particles. But what registered at 10:26 UTC wasn't routine. It was unprecedented, a ripple. Not a solar storm, not a coronal mass ejection. This was something subtler, but unmistakable. A coherent magnetic wave. It moved vertically, not horizontally, up through the layers of the magnetosphere rather than across them. That's not how solar plasma behaves. And it didn't originate from the sun. It came from deep space, from the direction of 3i Atlas. And then the data got even weirder. Simultaneously, ground-based magnetometers in Greenland, Siberia and northern Canada picked up a synchronized disturbance. Not a surge, more like a soft harmonic distortion. Think of it as the Earth's magnetic shield slightly wobbling, not under force but under pattern. It was responding. The timing matched the frequency split detected just minutes earlier from 3i Atlas. Let that sink in. A modulation in the comet's signal is followed almost immediately by a coherent reaction in Earth's magnetic field. Not hours later, not days, minutes. Scientists watching the event live were stunned. This wasn't like watching a lightning strike on the moon or a far-off gamma ray burst. This was local. This was personal. This was Earth flinching, reflexively, instinctively, as if it had just been pinged. A global magnetic reflex. The swarm satellites from the European Space Agency, which specialise in measuring Earth's magnetic vector field, recorded the same anomaly in near-Earth orbit. Their instruments showed a wavelet, a tiny transient undulation of the magnetosphere, shifting not with the sun but with a vector pointing toward the object hurtling toward Earth. It was almost poetic, as if our planet itself had sensed the signal and shivered, but that raised terrifying implications, because it meant whatever 3i Atlas was projecting wasn't passive, it was penetrative, and not just optically, it was coupling, somehow with the Earth's own field, not burning it, not breaking it, just touching it. That's the word researchers started to use behind closed doors. Touch. One NASA analyst described it like this. It was as if Earth was brushed by something conscious, something testing, not aggressive, just aware. Of course, that language never made it into the official report. The report used sanitized language. A typical magneto-electric resonance event, likely triggered by high-albedo interstellar object. But to the people who saw it happen in real time, those words didn't even come close, because Earth is not supposed to respond like this. It doesn't flinch unless hit. It doesn't ripple unless pushed. Yet on December 17th, it did both, without any physical impact, and every instrument that detected the event, radio telescopes, magnetometers, satellites, and even ground-based ELF sensors, showed the same conclusion. The object was interacting, not colliding, not radiating, interacting. And if that's the case, then we're not watching a natural visitor from deep space. We're in the middle of an active exchange. One side just happens to be speaking in waves and colour. The other, our side, is just learning how to listen. But the next question emerged almost immediately across all labs and research centres. If Earth's magnetic field is responding now, What happens when 3i Atlas gets even closer? Because in 2 days, there will be no atmosphere, no distance, and no shielding left. Only proximity. And proximity changes everything. By the time the magnetosphere had calmed, its ripples fading like echoes in a darkened cave, another phenomenon began to unfold. This one wasn't captured by satellites first. It was seen by the human eye. And not by scientists in labs, but by pilots. Commercial aircraft crossing the upper latitudes just before dawn began radioing in strange observations. Not auroras, not lightning, and not aircraft-related reflections. They were seeing a glow, a symmetrical arc of soft, vivid green lining the curve of the horizon, at an altitude far higher than most auroras ever form. Pilots described it as a ghost light. It didn't flicker, it didn't dance, it hovered. Still, silent, a complete band like a dome of neon mist pressing down gently on the Earth from above. But what startled most observers wasn't its colour, it was its timing. This halo appeared just 2 hours after the Earth's magnetic field had reacted to 3i Atlas. That proximity and pacing wasn't a coincidence, and more reports started flooding in. By the time air traffic logs were compiled from northern routes between Iceland, Canada, Alaska and Russia, a clear pattern emerged. The phenomenon was global, and it appeared in precise alignment with the twilight line, the thin boundary between Earth's night and day sides. It was as if the Earth had been traced. By dawn, satellites in polar orbits confirmed what pilots had seen. The green glow was not just visible, it was measurable, and not just to the visible eye. Instruments tracking the far ultraviolet and near-infrared bands saw spikes, but they weren't solar reflections, they weren't backscatter. The emissions were coming from inside the ionosphere. Something was lighting up the edge of Earth's skin. Here's what makes that terrifying. Natural auroras occur when charged solar particles collide with the gases in our atmosphere, oxygen, nitrogen, etc. The result is light. But these emissions didn't match that pattern. The spectral signature showed something unusual. It was almost purely oxygen-based, yes, but not from collisions. It was resonating. The oxygen atoms were being excited by something else, something rhythmic, something patterned. And there was only one direction in the sky that matched that modulation, the same vector as 3i Atlas. Researchers at the Finnish Meteorological Institute published a quiet note within their internal reports. The emissions matched the green absorption line of molecular oxygen when exposed to low-frequency electromagnetic fields under controlled lab conditions. But this wasn't a lab. This was the upper atmosphere. And then came the final puzzle piece. At 5:12 UTC, one of the Chinese weather satellites equipped with a wide-angle polar imaging array detected a brief dimming in the glow. Just a fraction of a second, but enough to register. That dimming wasn't local. It occurred globally, at the same time, around the entire atmospheric halo. That means the source wasn't on Earth. Something external had flickered, briefly, and the planet responded, again. Just like the magnetic shiver from earlier, this wasn't a one-way interaction. We were in a feedback loop. Every slight output from 3i Atlas, its colour, its rhythm, its pulse, seemed to echo inside our planet's systems. Not just as noise, but as instruction, as if Earth was being tuned. The green halo, which faded slowly after sunrise, left behind no damage, no trace, and no traditional atmospheric record. But for those who saw it, and those who measured it, it was undeniable. 3i Atlas had sent something, not just light, not just particles, a signal. And this time, Earth didn't just receive it, it responded in green. While the world slept through the strange emerald arc glowing above the planet's edges, the most sensitive instruments on Earth were already dissecting it. Specifically the radio observatories, the quiet ones, the ones built in valleys, far from cities, far from interference. The Greenbank Observatory in West Virginia, the Effelsberg Dish in Germany, and the Meerkat Array in South Africa all happened to be calibrated for a shared monitoring window during that early morning stretch. Not to watch 3i Atlas, but to monitor cosmic background frequencies and trace deep space interference patterns. What they caught, unintentionally, was a side channel. It began just after the halo appeared, and it lasted for only 19 seconds. 19 seconds of structured, rhythmic, low-band frequencies layered beneath the natural hiss of the cosmos. Not a spike, not a pulse, a pattern, and not just any pattern. It repeated, once every 4 seconds. That regularity would normally suggest some type of Earth-based interference. Think satellites, transmitters, even terrestrial reflections. But this didn't line up with any known man-made source. Each repetition carried a unique spectral signature, almost like a fingerprint, and yet all 3 observatories thousands of kilometers apart detected identical timing, identical spacing, identical signal strength. That's not possible unless the source is external and massive, but here's where it gets even more impossible. The direction of the signal's origin wasn't in deep space, it was directly aligned with the position of 3I Atlas. When plotted, the timing of the radio frequencies perfectly synchronized with the visual dimming event seen in the atmospheric halo, the moment Earth's green ring flickered for a heartbeat. The implication? We weren't just observing a physical response, we were listening to a communication protocol. At first, teams assumed it could be natural, a byproduct of electrostatic interactions, magnetic resonance, or particle decay. But natural events don't maintain precise timing across multiple frequency bands, and they certainly don't repeat with variation. Yet that's exactly what the 19-second transmission did. It had structure, substructure, as if each 4-second interval contained modulation, tiny shifts in pitch, phase and amplitude that varied in a progressive sequence. And in that sequence was embedded one trait human researchers dread discovering in space signals: non-random evolution. This signal was not looping, it wasn't static. Each loop added a new piece of information, stacking patterns, then reversing them, then mirroring them. The mathematics of the modulation echoed principles found in error correction codes, the kind humans use for interstellar messaging systems. But this didn't come from Earth, it was received by Earth. And it originated in the same narrow cone of sky where 3I Atlas now approached, pulsing brighter and greener with every passing hour. By midday, a quiet alert was issued to an international consortium of astronomers, not a warning, a classification shift. 3I Atlas had just transitioned, from observational curiosity to signal-emitting object of interest. The official phrasing, undetermined extraterrestrial modulated emissions, Class 3b. It wasn't labelled intelligent, but it wasn't dismissed as noise either, and while the press remained silent, still distracted by the glow over the poles, those inside the astronomical community had already begun cross-referencing old logs, looking back, reanalyzing old moments, searching for the signature. It wasn't there before, not in October, not in November, not even earlier in December. This green pulse began after Jupiter, after the encounter that no one at NASA has fully explained, and it only started after 3I Atlas began turning visibly green. Now Earth had heard it. Not a voice, not a language, but something deeper than either, a rhythm. And those who understand deep time, planetary resonance, and how objects like Atlas can influence fields without touching them, they understood what that meant. Earth was now inside the signal. The Earth has always hummed. Beneath the tectonic groans, above the rustling trees, and between the rumblings of the atmosphere, there's a background rhythm to this planet, an electromagnetic heartbeat that pulses between the ground and the ionosphere. Scientists call it the Schumann resonance. For decades, this resonance has held steady at around 8 Hz, fluctuating slightly during solar storms or geomagnetic turbulence. It's so consistent that some researchers even use it as a calibration tool for long-range sensors. But on the morning of December 17th, that heartbeat skipped. At first, the anomaly showed up in 3 independent monitoring stations, in Russia, Canada, and Italy. Each detected a faint upward shift in the baseline frequency. Not massive, not catastrophic, just different. A few tenths of a hertz higher. But what made it more than just noise was its consistency. Over the course of 8 hours, the frequency did not return to baseline. Instead, it climbed again. What made this climb especially perplexing was that it didn't follow the typical patterns associated with solar flares or geomagnetic spikes. The sun had been quiet, the solar wind was moderate, and yet the Schumann cavity, the space between Earth's surface and its upper atmospheric shell, was behaving like it had suddenly shrunk. Because that's what a higher resonance would suggest: a thinner cavity, a change in the electromagnetic boundary. But satellites measuring Earth's ionospheric density showed no such collapse, no compression, no thinning. Which left researchers with a strange paradox. Either the Earth's atmosphere had fundamentally changed in a way we couldn't detect, or something external was injecting frequency into the system. And that's when attention turned to 3i Atlas. Because just hours before this resonance anomaly began, the green glow surrounding the object had intensified again, visibly stretching its influence in every telescope frame. But this wasn't just light anymore. This was field interaction. Think of it this way. If the Schumann resonance is Earth's natural electromagnetic voice, then what happened on December 17th was like someone whispering into that voice and slightly altering its pitch, not enough to silence it, but enough to shift its key. The question no one wants to ask publicly: was it deliberate? Across Earth spectrum labs, those tasked with measuring EM fields for military, communications and research purposes, engineers began noting subtle phase offsets in long-distance radio bands, the kind used for undersea communication, for aviation, for Earth monitoring satellites, not disruptions, distortions, and each one seemed to align temporally with the brightening of 3i Atlas. Now here's the part most haven't heard. A subset of EEG labs, those that study human brainwave states, began reporting strange anomalies that same morning. Volunteers in sleep studies, meditation clinics, and neurofeedback centers all exhibited slight shifts in alpha and theta wave dominance. Nothing dangerous, but measurable, documented. And just like the Schumann signal, they didn't return to baseline. The leading theory: when an object like 3i Atlas, whatever it is, reaches a proximity close enough to exert subtle EM field influence on Earth's natural cavities, you don't need a beam, a wave, or a visible signature. You only need one thing: resonance overlap. When two systems begin to interact at shared frequencies, even weak signals can cause entrainment, when one rhythm locks onto another. And on that morning, Earth's rhythm locked onto something else, something green, something steady, something approaching. And those paying attention realized something even deeper. This wasn't just a scientific curiosity anymore, it was planetary entrainment. Earth had joined a system, and the heartbeat we thought was ours alone now had company. On maps, the equator is a clean cut across the belly of Earth, a geographic line drawn halfway between the poles. But Earth has another equator most people never think about, one you can't see on satellite images or feel underfoot. It's called the magnetic equator, the invisible band where the planet's magnetic field points perfectly horizontal, running perpendicular to the force lines that dip toward the poles. For decades, this magnetic equator has been slowly drifting. Scientists have tracked it moving westward at a steady pace, pulled by complex interactions in the liquid iron core beneath our feet. It's subtle, predictable, governed by internal dynamics deep below Earth's crust. But on the morning of December 17th, that predictability began to unravel. Across a network of magnetometer stations, from Quito to Lagos, from Kuala Lumpur to the islands of the Pacific, technicians began flagging subtle but synchronized anomalies. These weren't spikes or bursts, they were shifts, measured in angles, measured in time, and most disturbingly measured in pattern. The horizontal component of Earth's magnetic field, the one that defines where the magnetic equator lives, began to tilt. At first, it was minor, less than a fraction of a degree, but it didn't stay that way. Over the next 10 hours, the field lines began drifting in a coordinated arc, away from their expected westward path and bending ever so slightly toward the direction of 3i Atlas's approach. That was the first red flag. Because while Earth's magnetic field is not fixed, its long-term movements are glacial. Changes happen over centuries, not hours. And yet, on this particular morning, something seemed to be pulling at the core. Not from within, but from without. By midday, analysts at the European Space Agency's Swarm satellite program, which tracks magnetic variations across the globe, confirmed what ground stations had already suspected. The magnetic equator had shifted, not permanently, but noticeably. It had stretched southward over the Pacific, a deviation large enough to be measurable, but too soft to trigger alarm systems designed for solar storms. It wasn't until a private geomagnetic observatory in French Polynesia published their findings that the connection became harder to ignore. Using high-resolution magnetograms, they traced the field's drift to a vector aligned precisely with the current trajectory of 3I Atlas, a trajectory that, just hours earlier, had crossed an angular threshold between Earth and the Sun's outer magnetic shell. That's when the second red flag appeared. The Earth's magnetopause, the boundary where our planet's magnetic field pushes back against the solar wind, began to ripple, not from a CME, not from solar particles, but from something else, something rhythmic. Magnetometers in low Earth orbit picked up pulses, faint oscillations in the field spaced evenly apart. These were not chaotic spikes. They were timed, measured, almost mechanical. And within minutes of each pulse, the magnetic equator twitched, just slightly, as if the planet's core were reacting to a series of silent nudges from something vast, coherent and impossibly distant. That was the third red flag. We've always known that Earth's magnetic field is responsive. It breathes, it flexes, but it is not supposed to synchronize with anything beyond the heliosphere. And yet here it was, subtly dancing to the beat of an object glowing brighter every hour in our sky. The implications are unnerving. If 3I Atlas is capable of interacting not just with light, not just with radiation, but with the geomagnetic architecture of our planet, then this is no longer just a story about astronomy. It's a story about systems, interlinked, entangled. And the magnetic equator, once a silent boundary beneath our feet, has become a messenger, a signal that Earth's interior is hearing something it's never heard before, and it's moving in response. Light is more than colour, it's data. When an object emits light, it's not just glowing, it's speaking. Every star, every gas cloud, every comet releases a specific pattern of wavelengths that act like a barcode. Astronomers call these spectral lines, and they allow us to tell what something is made of, how fast it's moving, how hot it is, and even whether it's spinning. We have catalogued thousands of these patterns over decades, from the deepest black holes to the faintest remnants of interstellar dust. But on December 17th, the tools we built to understand light returned something that didn't fit. It started just after sunrise in the southern hemisphere. Ground-based observatories in Chile, South Africa and Western Australia pointed their multiband spectroscopes toward 3I Atlas, tracking its gold-toned coma and increasingly intense tail. The goal was routine: gather spectral data to analyze the material the comet was releasing as it approached Earth, but within minutes the data streams triggered their first alerts. Not because of intensity, but because of discrepancy. Instead of the expected signatures, like water vapour, carbon monoxide or dust fragments, telescopes started receiving wavelengths in non-terrestrial bands. These were readings outside the infrared, visible and ultraviolet ranges. At first glance they seemed like noise, background static, but they weren't. They were structured. The pattern repeated every 91 seconds. A pulse. Each time a unique band of wavelengths shimmered into detection, then disappeared, then reappeared in a slightly altered state, drifting but never dissolving. It was like watching a sentence unfold word by word in a language no one had ever heard. But it didn't stop there. The ALMA Observatory in Chile, one of the most advanced radio telescope arrays on Earth, received an even stranger signal. 3I Atlas was broadcasting in the terahertz range, a spectral band between microwaves and infrared light. It's a region rarely used in deep space astronomy because it's usually empty, silent. But now it was alive. The terahertz pulses weren't just random flares, they were sequenced, tightly grouped, timed. Each burst was accompanied by a fractional increase in the visible green hue surrounding 3I Atlas's coma, almost as if the object was sinking light with something deeper. By noon, satellite instruments in orbit around Earth, like ESA's Solar Orbiter and NASA's stereo probes, confirmed the readings. The emissions weren't localized. They extended in a radial formation around the comet, creating a multi-layered shell of energy bands stacked like ripples in a pond. But ripples from what? Scientists began comparing the data to known emissions, pulsars, quasars, gamma-ray bursts. None of it matched. The fingerprint was unique. No known comet, natural or otherwise, had ever produced this kind of output. Not even the mysterious interstellar objects before it, like Oumuamua or Borisov, came close, and then came the optical anomaly. At 2:04 p.m, the Las Campanas Observatory reported a green flare, brief but blinding, emanating from the core of 3I Atlas. It lasted less than a second, but it registered across the full EM spectrum, including polarizations that typically don't reflect from cometary ice. In the moments that followed, the comet's visible hue deepened. It became less mint-coloured and more electric, almost metallic in tone. The green wasn't just a colour anymore, it was a carrier of information, of structure, or something we don't yet have a name for. Whatever it wasn't behaving like a dusty ice ball being warmed by the sun. And perhaps the most chilling part wasn't what we saw, but what we didn't. Because in the heart of those strange emissions there were gaps, regions of total silence, where no wavelength, no pulse, and no trace of matter could be detected. Like commas in a sentence, as if the signal knew when to pause, before continuing. For comets, tails are supposed to trail behind. That's one of the first principles we teach about these icy bodies. When sunlight heats the surface, it vaporizes ice and dust, pushing material outward in the direction opposite the sun. That forms the classic glowing tail, often stretching millions of miles into space. But every now and then, a rarer phenomenon appears, the antitail. An antitail doesn't point away from the sun. It appears to lead the comet, pointing toward it, as if the object is somehow drawing material in rather than ejecting it. In most cases, this is just a trick of perspective. Earth's angle, combined with the comet's motion and orbit, can cause debris in the orbital plane to reflect sunlight in such a way that it looks like the comet is pulling a tail toward itself. But this wasn't that. On the morning of December 17th, astronomers across 5 continents logged a subtle but undeniable change in the shape of 3I Atlas's anti-tail. It had begun to bend inward. At first, it appeared as a distortion, an optical effect caused by solar wind fluctuations or camera drift. But further measurements confirmed what the eye suspected. The anti-tail, which previously extended in a nearly straight fan-like projection, was now curling, arcing slowly back toward the body of the comet like a reversed question mark. This alone would be unusual, but it's what came next that made researchers sit up. The anti-tail didn't just curve, it tightened. Over a span of just 5 hours, high-resolution imagery from the Subaru telescope in Hawaii showed the outermost layer of the anti-tail collapsing inward, as if drawn by an invisible tether. The particles were not dispersing into space, they were rejoining, and they were accelerating. Analysis from the University of Arizona's Skylab team revealed that dust particles within the anti-tail were moving toward the nucleus of 3I Atlas at speeds far higher than solar gravity or magnetic drag could explain. It was as though something inside the comet was pulling, with intent, with rhythm, and with precision. Not only that, the structure of the anti-tail had changed. Instead of the usual diffuse stream of gas and microdust, the anti-tail now displayed layered filaments, nested like veins or cables. Spectral analysis showed a new material composition emerging. Nickel-rich compounds laced with silicates, but structured in parallel strands. Natural outgassing doesn't create patterns like that. The shape, the density, the inward motion, it didn't look like something breaking apart. It looked like something building, and then came the colour. As the anti-tail curled tighter, a shimmer of the same electric green from the comet's core began to trace along the outer edges of the structure. It wasn't glowing uniformly. It pulsed, travelling from the tip of the anti-tail back toward the comet in cycles that matched the terahertz bursts recorded the day before. This timing wasn't coincidence. The spectral shift, the curvature, and the movement were in sync with the strange signal patterns picked up across global radio observatories. 3I Atlas wasn't just emitting light or gas anymore. It was broadcasting structure, wavelengths that corresponded to actual motion, as if the object was constructing or reabsorbing elements of itself. Something changed deep in the core. That's when a new anomaly appeared, one no one expected. For exactly 23 seconds, the anti-tail disappeared entirely from all optical scopes. Not faded, not dimmed, vanished. Instruments that tracked its structure down to sub-arc-second levels lost all trace, like a digital wipe. When it returned, the tail had shortened dramatically, and it no longer pointed forward. It pointed downward, a vertical shift suggesting a change in orientation or gravity anchoring. The implication was unsettling, because if the anti-tail had truly bent, collapsed, and fused with the main body, then this wasn't an evaporation event anymore. It was a reclamation, a return. Something about 3i Atlas had reversed the natural order, and in doing so it blurred the line between destruction and design. We measure its wavelengths, we split it through prisms, we track its reflections and absorptions across every material known to science. It illuminates, reflects, bends, refracts, but it never vanishes without cause. But on the morning of December 17th, a discovery was logged that defied everything light is supposed to do. At precisely Jiasu 4:21 Coordinated Universal Time, the European Space Agency's solar monitoring satellite Sentinel-9 recorded a dark pulse. It was brief, unremarkable at first glance, a simple dip in illumination across the visible spectrum. But the telemetry flagged it immediately, because the signal wasn't just a dimming of light, it was a complete inversion of expected photonic return. The surrounding region around 3i Atlas didn't just absorb more light, it acted as though it was emitting darkness. This wasn't a shadow, it was a negative imprint on the fabric of detection itself. NASA's Solar Terrestrial Relations Observatory, running in parallel orbit, caught the same anomaly 34 seconds later. Instruments that rely on visible, ultraviolet, and even infrared spectroscopy all returned the same conclusion. For a short span of 9 seconds, a perfectly spherical region around 3i Atlas stopped reflecting light, stopped emitting heat, and began registering less than background radiation. That is, somehow, it was colder than the space around it. This phenomenon, dubbed negative light, has no place in classical physics. Even the darkest known regions of space, the voids between galaxy clusters, still echo with background radiation from the Big Bang. But this sphere, centered on 3i Atlas's newly tightening anti-tail, dipped below that baseline. It wasn't just invisible, it cancelled the act of seeing. The effect was localized, not expanding like an eclipse or corona. It hovered in place for 8.8 seconds, then collapsed inward, like a pop with no sound. When the light returned, it didn't come back gradually. It snapped, instantly. And what replaced it wasn't the same. The tail had changed shape again, more defined, denser, now exhibiting structural ridges that extended laterally like spokes. But even stranger, surrounding the tail and the main nucleus was a halo, barely perceptible in normal light, but sharply defined under terahertz imaging. A ring, not gas, not dust. A structured, rotating band encircling the center of 3i Atlas at roughly 150 degrees off the orbital plane. It glowed faintly in only one frequency band, deep ultraviolet, and this is where things truly crossed into the impossible. According to measurements from 3 separate instruments, China's Chang'e 7 solar array, NASA's Parker solar probe, and an independent balloon-borne telescope above Chile, that UV emission wasn't radiated outward. It flowed inward, as if the ring was feeding the comet. The wavelengths were negative shifted but not red shifted by motion. Instead, they appeared inverted, like a mirror of the known spectrum. Spectral fingerprints were scrambled, phase-locked in patterns never before charted in deep space. This was not an atmospheric interaction. This was not dust behaving strangely in sunlight. This was a deliberate frequency behavior centered around a static ring in a place where no natural material should hold formation, let alone rotate. The implications triggered immediate security-level alerts. Within minutes, several observatories around the world, Lick, Mauna Kea and La Silla, received do not disclose notices related to the anomaly. Data feeds were temporarily rerouted through centralized review hubs. Public-facing satellite live streams experienced temporary outages or data integrity flags, and through it all 3i Atlas kept glowing, but no longer in green. From this point on, high-resolution imagery began picking up slight amber tones, bleeding through the base of the nucleus. Something had changed, not just around the comet, inside it. And the ring wasn't fading, it was tightening, sharpening, as if closing in on the body itself, like a seal, a lock, or worse, a countdown. It began as a low throb, barely perceptible, not a flash, not a beam, just a soft, repeating signal buried deep within the data stream. At first, it was thought to be solar interference, common enough when dealing with objects this close to the Sun. But as more instruments tuned their arrays toward 3i Atlas, the signal became undeniable. The core of the comet was pulsing, not randomly, not chaotically, but with rhythmic precision. One pulse every 4.8 seconds, not visible to the naked eye but unmistakable in the magnetic field data. Each cycle generated a soft electromagnetic wave, too weak to affect satellites, but strong enough to register across multiple bands, including radio and ELF frequencies. And then something far more bizarre was discovered. The waveform matched the Earth's Schumann resonance. The Schumann resonance is a natural electromagnetic phenomenon that encircles the Earth. It's formed by the space between the Earth's surface and the ionosphere, creating a kind of planetary cavity. This cavity resonates like a drum, pulsing primarily at 7.3 Hz, a frequency sometimes called the planet's heartbeat. And now 3i Atlas was mirroring it. More precisely, it was pulsing at exact harmonic multiples, 7.83, 15.66, 23.4, all the way to 45.9, frequencies that have never been detected in the tail or core of any known comet. Not once, not in recorded history, not in samples taken from Halley's comet, not from Rosetta's Philae lander, not from any data gathered from interstellar interlopers like 2i Borisov or Oumuamua. This behavior was not natural. Nature doesn't tune itself to Earth's electromagnetic frequency. More curious still, the pulses originated not from the comet's surface or tail, but from deep within its core. Instruments tracking rotational dynamics noticed that the pulses remained consistent even as the comet's angle shifted. That meant they weren't reflections. They weren't caused by sunlight or orientation. They were self-generated, and they grew slightly stronger every hour. High-resolution spectral analysis from ground-based arrays in Hawaii confirmed that these pulses were accompanied by subtle changes in the tail structure. The core seemed to expand slightly with each pulse, no more than a few meters in visible diameter, then contract again, like a beating heart. A pulsing core, a synchronized rhythm, a matching planetary frequency. Scientists in multiple observatories raised the same question in private forums. Is this a signal? There's precedent for interpreting repeating rhythms in space. Pulsars were once believed to be alien beacons before their neutron star origin was confirmed. Quasi-periodic oscillations in black holes generate echoes that mimic intelligent signatures. But this was something different. This was precision timing specifically tied to Earth's own background resonance. It would be one thing if 3i Atlas had mimicked a solar frequency or echoed radio background from galactic sources. But this was narrow band, targeted, coordinated. Worse, it was amplifying. Each pulse became a little more defined. The harmonics grew cleaner. By the 7th hour of observation, the waveform wasn't just mimicking Earth, it was in phase with it. Imagine two singers aligning their voices so precisely, their tones merge into one. That's what was happening. A celestial object deep in space, somehow syncing itself to the electromagnetic frequency of a specific planet. Ours. When observatories tested for possible terrestrial interference, hoping perhaps some satellite was responsible for a feedback loop, they found none. The source remained fixed, stable, and approximately 22 million kilometers from Earth, where 3i Atlas had moved that morning. A pulse from its core, a frequency from its heart. And Earth was answering, unintentionally perhaps. But the ionosphere began responding, microbursts in the upper atmosphere that matched the incoming phase, like ripples reacting to a stone dropped into water. Not loud, not dangerous, not yet, but resonant. And when the two systems hum in harmony for long enough, one of them always starts to change. At first it was only a flicker, a barely measurable dip in the magnetosphere over the South Pacific, just a localized anomaly, one of thousands that happen every week due to solar wind variations, auroras, or transient energy bursts in the upper atmosphere. But something about this dip felt deliberate. It occurred precisely 20 minutes after the latest rhythmic pulse from 3i Atlas, a pulse that, as we now know, was already in lockstep with Earth's own resonance. The shape of the magnetic disturbance mirrored the harmonic wave detected from the comet's core. Not random, not scattered, synchronized. Within hours, multiple satellite systems began to pick up the same pattern. ES's Swarm constellation, designed to monitor Earth's magnetic behavior, registered slight but unusual lateral displacements in the equatorial magnetic field lines, measured not just in strength, but in alignment. In simpler terms, the lines that usually flow around Earth like an invisible shell had begun to twist, ever so subtly, toward the direction of 3I Atlas. No known comet has ever done this. Even during close solar flybys, massive comets like Hale-Bopp or Neowise didn't cause measurable magnetic alignment from Earth. It would take a magneto-strength field to shift the Earth's natural magnetic shell in any consistent direction. Yet here we were, facing microscopic but growing distortions, all pointing toward a single object hurtling toward us, an object now less than 21 million kilometers away. The timing was precise, the rhythm unbroken. Every 4.8 seconds another pulse, every few minutes a small corresponding shift in magnetic data, not everywhere at once, only in key atmospheric bands over the Atlantic, Southeast Asia, and portions of the Arctic. Regions known for their sensitivity to electromagnetic influence due to weak spots in the magnetic shell. Scientists at NOAA's Space Weather Prediction Center began cross-referencing data from aurora indexes, solar wind monitors, and historical records. Nothing matched. No solar storm had occurred. The sun had been quiet for days. No CMEs, no coronal holes, no significant flares. The ionosphere should have remained stable, and yet the twisting continued. Minor deviations in electron density, slight elongations in the Van Allen belts, enough to raise eyebrows, enough to move compasses by fractions of a degree, detectable only by the most precise instruments. But the trend line was clear. 3I Atlas wasn't just emitting a pulse, it was beginning to exert influence. And this wasn't gravity. Gravity acts slowly and evenly. A comet like 3I Atlas doesn't have enough mass to move Earth's orbit or shake its field. But magnetism works differently. It requires resonance, frequency, alignment. And this comet had all three. By midday, ground-based magnetometers in Japan, Chile, and Central Africa had all independently confirmed the anomaly. Field lines weren't just drifting. They were oscillating, wobbling back and forth in cycles that perfectly mirrored the pulse train from the comet. More alarmingly, certain geosynchronous satellites began reporting signal errors. Not outages, just delays, phase drift. Timing lag between expected signal return and actual bounce, a few milliseconds at most. But enough to matter, enough for orbital engineers to begin checking their fail-safes. And then came the quiet note from the European Space Agency. One of their magnetospheric observatories had picked up a sudden flux inversion, a tiny one, but still an inversion, in the lower ionosphere. In layman's terms, the polarity flipped just for an instant in a small pocket of air high above the Atlantic, as if something had momentarily whispered a different set of instructions to Earth's natural shielding. It flipped, and then reset. No damage, no fallout, but no explanation either. The question on everyone's mind wasn't what was causing the shifts. We knew the source. The comet had made itself obvious. The question was, how? How can an icy object from interstellar space be tuned so precisely to our planet's hidden heartbeat? How can it pulse in sync with Earth's resonance, and then begin to change the very field that protects us? The next pulse was stronger, and this time, the sky turned green in places it shouldn't have. Not over the Arctic, not above northern Canada or Scandinavia, or the usual corridors lit by solar particles. These lights flickered to life above the skies of India, Colombia, and central Spain, locations far outside the normal auroral ovals. And what made them even stranger, these weren't sweeping ribbons of colour that moved with the wind. These were vertical, almost stationary curtains of green, pulsing like radar dishes caught mid-transmission. The first reports were dismissed as camera lens flares or local light pollution, until someone in Morocco live-streamed one. It wasn't a time-lapse, it wasn't distorted, the sky was glowing, and the colour was wrong. Not just green, but an electric, saturated green, deeper than most auroras and laced with specks of gold at the edges. Scientists at the Atmospheric Imaging Assembly in France began comparing satellite data from the same hours. Their ultraviolet detectors hadn't picked up any significant solar flux. The sun was calm. No coronal mass ejections, no flares, no increase in solar wind speed. But every glowing region on Earth lined up precisely, down to the latitude and magnetic field orientation, with the incoming trajectory of 3I Atlas. The comet, now inside Earth's orbital radius, was casting invisible waves, and somehow those waves were lighting the upper atmosphere. The big reveal came from data shared quietly between the Japanese Aerospace Exploration Agency and the European Space Agency. Their joint electromagnetic imaging experiment had picked up structured waveforms passing through the ionosphere, consistent not with natural auroral formation, but with directed resonance pulses. In other words, someone, or something, was deliberately exciting Earth's upper magnetic shell in specific regions, and the effects were visible from the ground. A group of amateur astronomers in northern Egypt caught one of the events on film. The footage is silent, shaky, handheld, but it captures something unmistakable: a flash of green, then a slow fade, followed by a triangular shimmer that lasted 3 seconds before vanishing into darkness. Not a shape caused by clouds, not weather balloons, not lightning. What they filmed looked like a structured auroral pattern, reacting to a command signal from above. By this point, weather stations in the southern hemisphere were registering pressure shifts at high altitudes, too high to be tied to storm systems, yet too localized to be dismissed as planetary tides, and each shift corresponded with a slight increase in electromagnetic tension, like something was rubbing against Earth's outer atmosphere from afar. That something had a name: 3I Atlas, and as the comet drew closer, its green hue grew brighter, deeper, and more coherent. No longer just light refracted by solar radiation. The green glow appeared to intensify at specific angles, depending on where Earth's magnetic field was facing. Satellites showed bands of resonance stretching like spiderwebs across the sky. Not random, but geometric. And it wasn't just happening at night. By mid-afternoon over Peru, commercial airline pilots began reporting faint green arcs across the daylight sky, visible only through polarized cockpit windows, but still there. High-altitude sensors registered unusual trace particles in the stratosphere, possibly ionized oxygen, yet not from solar UV. These particles were oscillating, caught in a high-frequency wave that matched the same 4.8-second pulse from earlier chapters. And then came the audio. Somewhere in the Colorado Rockies, a deep space radio observatory picked up what sounded like an artificial hum inside the frequency range used to track auroras. It wasn't a signal, it was a tone, a repeating note that slightly shifted pitch every 9 cycles, mimicking musical harmony. Auroras don't hum, but this one did. What appeared to be a comet had turned into a resonance beacon, activating Earth's magnetic veil in ways we had never observed. And now, for the first time, we had visual evidence that 3I Atlas was more than a passive object. It was engaging. One scientist at a private observatory summed it up perfectly. This isn't the atmosphere reacting to a comet. This is a comet reaching out, tuning Earth like an instrument. And the next chapter would show just how deep the music goes. Until now, most of what we observed from 3I Atlas had remained in the skies. Its glow, its strange jets, its coordinated pulses along the ionosphere, all dramatic, all stunning, but all still distant. That changed when the pulse reached the ground, and then kept going. Straight into the Earth, it started with a subtle anomaly. Geophysicists operating out of Reykjavik noticed something strange in their daily magnetic drift logs. Earth's magnetic North Pole, which typically drifts by a few meters a year, had shifted over 7 meters in a single day. Not only that, it had changed direction. Instead of continuing its slow curve towards Siberia, it bent westward, veering toward a path that, when projected, aligned perfectly with 3I Atlas's inbound vector. That was no longer just drift, it was redirection, and the deeper they looked, the stranger it got. High-precision gravimeters deployed in the Himalayas registered a slight change in gravitational tension, as if the mantle itself was adjusting to accommodate something. But there were no tectonic events, no pressure spikes, no quakes, just an eerie, global resonance that moved like a low-frequency wave across Earth's interior. It didn't happen all at once. First came Brazil, where scientists tracking the South Atlantic anomaly, a region where Earth's magnetic field is already weak, noticed it expanding at 3 times its normal rate. Instruments that had remained stable for years suddenly began blinking red. Not from hardware failure, but from environmental mismatch. The numbers simply didn't make sense. Then came Alaska. At the Poker Flat Research Range, used to measure magnetospheric fluctuations, staff found that baseline field strength readings had become unstable. Even in calm solar conditions, the flux lines were bending, as if being tugged by an invisible rope from deep within the planet. Not from above, not from below, but from the center. Seismologists began comparing data, and one term kept resurfacing: core oscillation. A normally theoretical concept, referring to tiny wobbles in Earth's iron core that occur over hundreds of years, was now measurable in real time. Earth's inner core was no longer steady, it was moving, and not on its own terms. The oscillation had become rhythmic, repeating every 4.8 seconds, the same signature observed in the earlier atmospheric pulses from 3I Atlas. There was no mistaking it. The comet was not just affecting our skies, it had reached inside the Earth. The implications were staggering. If a celestial object could generate waves strong enough to penetrate the magnetosphere, pass through the crust and interact with the core, then we were no longer dealing with passive astronomy. We were looking at interactive planetary influence, something akin to remote manipulation. That's when new data arrived from the Borexino detector in Italy, a neutrino observatory deep underground. Neutrino counts were off the charts, but not because of a solar event or distant supernova. These neutrinos had a local signature. Their angles of entry and velocity scatter suggested they weren't coming from the sun or even from space. They were being reflected, bounced, or generated inside Earth. One physicist on the team phrased it carefully. It's as if a high-frequency pulse is causing atomic rearrangements, releasing neutrinos in patterns we've never documented before. In plain terms, the Earth's core might be responding, or worse, it might be resonating. NASA and ESA issued no public statements, but privately, sensors at magnetically sensitive sites across the globe were put on high alert. Their operating thresholds were recalibrated, as if preparing for a planetary-level magnetic event. And then something eerie happened. In an old Russian mine converted into a research facility, an array of magnetic sensors detected a reverse echo, a bounce back from Earth's core, directed not at the surface, but towards space. As if the Earth had responded to 3I Atlas with a signal of its own, not an answer, not a warning, but something alive. And the next chapter reveals what happens when the planet begins to vibrate in harmony with something it didn't invite. It started as a tremor in the data. Nothing visible, nothing audible, just a subtle fluctuation in readings that had, until now, been stable for decades. The global magnetic field of Earth, that invisible bubble of protection shielding us from cosmic radiation and solar winds, was no longer behaving like a rigid structure. It was rippling, not rotating, not fluctuating, but rippling. Like the surface of a lake when a stone is dropped into it, except this lake was planetary in scale, and the stone wasn't even on Earth. From research stations in Finland to underwater observatories in the Mariana Trench, magnetometers began reporting an unprecedented wave pattern. A planet-wide undulation of the magnetic field that pulsed not outward from the sun, but inward from the center of Earth and then upward back into the atmosphere. At first, scientists thought it was just equipment drift. They recalibrated, they checked for interference. But the readings persisted. In fact, they became more synchronized, a standing wave pattern forming across the planet's entire magnetic envelope. It wasn't chaotic, it was deliberate, rhythmic, pulsing every 4.8 seconds, exactly the same frequency observed in the earlier green light fluctuations of 3I Atlas. The realization came hard. The magnetic field was behaving like a fluid membrane, responding not to solar storms or Earth's rotation, but to something outside the Earth-Sun system entirely, something it had never encountered before. That something was now just 2 days away from its closest pass to Earth. To observers on the surface, there was nothing obviously different. Your compass still worked, GPS satellites still gave accurate coordinates, but at the quantum level, where the laws of physics become fluid, the field was vibrating, realigning and stretching. One of the first to raise the alarm was Dr. Eliza Harmon, a geophysicist based at the Amundsen Scott Station in Antarctica. Her team noticed that auroras were forming in the lower atmosphere not just near the poles but close to the equator. But these weren't like typical auroras. They moved too fast. They shimmered like heat waves, and most unnervingly they followed the same frequency pulse that had been measured underground, underwater, and now in the sky. Something was knitting it all together. It wasn't just Earth responding to a comet. It was the entire electromagnetic system of the planet being brought into coherence. Across the Pacific, the Japanese satellite Hisaki, which monitors extreme ultraviolet emissions, began picking up magnetic reconnection events not near the Sun, but near Earth. These are violent snaps of magnetic lines that usually occur during solar flares. But these ones weren't solar. They were Earth-born, generated by the rippling magnetic field itself. The lines snapped, energy burst outward, and tiny jets of charged particles erupted, not just into space, but downward into the upper atmosphere. Theoretically impossible. Yet there it was, measured, verified, recorded. This posed a terrifying possibility. What if Earth's magnetic field wasn't just shielding us from space? What if, under specific frequencies, it could become a conduit, a bridge between Earth's core and the objects influencing it? Suddenly, ancient stories of auroral whispers and electromagnetic hauntings didn't seem so far-fetched. Not myths, maybe memories. And still, the ripples grew. Global satellite arrays began adjusting their orbits. Communication satellites quietly boosted redundancy systems. Airlines rerouted flights away from the poles, not because of solar flares, but because the field was unstable. The surface of our world remained calm, but above it, and beneath it, a kind of harmonic war was being waged, between Earth's natural defense systems and an object whose very glow was reprogramming them. What was this ripple preparing us for? The answer would come at zero distance, when 3i Atlas would pass within the gravitational breath of Earth. And it's in that moment, during closest approach, that the most unbelievable transformation of the comet would finally be revealed. It happened without warning. No seismic tremor, no solar flare, no gravitational spike, just silence. And then, 3 Atlas disappeared. Not behind the moon, not into shadow, not into dust. It became transparent. From over a dozen telescopes live streaming in multiple wavelengths, the same bizarre phenomenon was recorded. As the comet reached its closest pass to Earth, something occurred that even the most seasoned astrophysicists could not explain. The glowing green structure that had defied logic for weeks began to shift, not just in brightness, but in form. Its chroma didn't dim, it didn't fade, it simply flattened, then dissolved, leaving behind the faintest outline, a spectral echo hovering in the blackness of space. Like a glass sculpture held in moonlight, it shimmered without substance, and then, just for a moment, it returned. But not where it should have been. 3i Atlas had jumped, not in orbit, not through gravity, but through visibility. It reappeared tens of thousands of kilometers off course, then again, closer, then gone. Like a blinking signal or a coded transmission, it phased in and out of our observable spectrum in rhythmic pulses, with millisecond precision. Every major observatory on Earth was watching, but none could track it with consistency. Even NASA's Deep Space Network went temporarily blind. In Hawaii, the Pan-STARRS telescope reported that its near-infrared scans showed not one, but 3 simultaneous afterimages of the object trailing like a cascade of folded space. But how could a comet, something born from rock and ice, perform tactical cloaking? It couldn't, unless it wasn't a comet at all. That was the conclusion quietly reached, behind closed doors by teams at JPL, ESA, and even private space tracking groups. They no longer referred to it as a comet in their internal documentation. The new term? Phase-shifted object. Because what passed closest to Earth wasn't solid, not in the way we define matter. It behaved as if it could selectively obey or ignore the rules of reflection, light absorption, and even positional locality. The most shocking evidence came from an unexpected source, a set of military-grade LiDAR scans from an undisclosed balloon over the South Pacific. These scans showed that as 3i Atlas approached, the atmosphere directly above it compressed, not due to speed or mass, but to displacement. It was as if the comet wasn't just passing through space, it was passing through dimensions. The implications were staggering. If this object could step between visible states, between gravitational pulls and between electromagnetic signatures, then it wasn't just advanced, it was architected. And yet, for all its bizarre behaviour, it never acted hostile. No debris, no harmful radiation, no course correction toward Earth. It never slowed down, never threatened to collide. It simply got closer, turned greener, grew quieter, and then vanished into the most complex optical illusion space has ever seen. And then came the final twist. Just as Earth's field stabilized, no more ripples, no more harmonic pulses, the night sky blinked. In one final burst of gold, the object pulsed once, then faded. Not into space, not into darkness, but into something else entirely. As if it had completed its pass, performed its function, and was now beyond our ability to perceive. The silence returned, the field calmed, the auroras vanished, and Earth continued to spin. But somewhere, on hard drives, in observatory logs, in whispered government channels, the records remain that for exactly 3 minutes on the morning of December the 17th, an object from the void turned transparent, then performed a maneuver no known natural body has ever exhibited. 3i Atlas didn't crash, it didn't burn, it didn't shatter, it shifted, and left behind only questions. There are moments in human history that feel like punctuation marks, small, sharp events that divide what came before from everything that will follow. This was one of them. The appearance of 3i Atlas challenged the language we use to describe reality. It glowed in ways no chemical reaction could explain. It moved with precision that mocked our equations. And as it came closer, it didn't grow louder. It grew calmer. No tale of destruction, no gravitational panic. Just a radiant object, turning 33 times greener, shifting form, pulsing in silence, and then disappearing. The scientists who watched it aren't calling it a comet anymore. The analysts reviewing its final pass aren't sure it had mass at all. And the agencies that track near-Earth objects are quietly rewriting definitions behind closed doors. But maybe the truth is simpler than we think. Maybe we weren't meant to understand 3i Atlas in the traditional sense. Maybe it was never about a threat. Maybe it was a test, a measurement, a signal sent through light, form, and behaviour. Not to harm, but to observe. To see how we'd respond, how much we'd notice, and whether we were ready to admit we don't fully control the sky. Because what passed Earth on the morning of December 17th didn't just move through our space, it moved through our understanding, and somewhere out there, beyond the radio waves, the infrared spectrums and the limits of our language, it's still watching, still shifting, still waiting for the next moment of contact, so keep your eyes open and your silence ready. Because the universe doesn't shout, it whispers, and this time we heard it.